Hello guys, welcome to the knowledge domain, the concept of life sciences and biotechnology. Today we are going to discuss an experimental system in the method section, the agglutination, the cross-linking that occurs between di or the multivalent antibodies against multivalent bacterial or other cellular antigen can result in a visible clumping of the complexes formed between cells bearing the antigen and the antibody molecule. This clumping reaction is called agglutination. Antibodies that produce such reactions are called agglutinin. Agglutination reactions are identical in principle to precipitation reaction. Only difference is in agglutination reaction, the cross-link products are visible to naked eyes and larger size of antigens are involved in this case. Hemagglutination reactions is used to detect any antigen conjugated to the surface of the red blood cell. This is an example to understand how the agglutination reactions happens and how the clumps looks like. So we can see here there are the 10 points, there are 1 to 9 is 1 and the point number 10 is the control tube that contains only the shift red blood cells and which settles into a solid bottom. We can see like this. And 1 to 9, this is the serial dilution by half. So this is the concentrated the blood, the number of the 1 to 9 number of the SIP RBCs. So this is the as the blood is taken, this is as it is like this. This is half diluted, this is 4 times diluted, and it continues. This is 1 by 8, and this is 1 by 16, 1 by 32, 1 by 64. Like this, the dilution goes on. So here we can see that when it is as it is the SIP blood and it is half diluted, it is 1/4 diluted, we can see the spread pattern that indicate the positive hemagglutination. So up to dilution 1 by 4, we can see that there is a hemagglutination reaction is happening. So coming to the use of the hemagglutination, the agglutination reaction for the blood typing. So this is the antibody or the antiserum against the human antigen A. It is against the antigen B, and this is the Rh antigen. So we have the three types of the antibody that we put at antisera against the antigen A, B, and the Rh antigen. And here, this is the same blood. It is the blood of the same individual that is put on the as three spots A, B, and the C. And in the A, we don't see there is any clumping formation or the agglutination reaction. We don't see any agglutination reaction in the B as well as the RH. So this person is the O negative. In another individual, we can see no clumping, and we can see the clumping or the precipitation or the agglutination only in the RH. Against the RH means in the sample containing blood and the antisera are. So this person is the O positive. And coming to the third individual, we can see that antisera A is showing the agglutination reaction, whereas the antisera B and the RH antisera are not showing any agglutination reaction. So this individual is A negative. Whereas in this individual, you can see the agglutination reaction in case of the antisera A or the antibody A plus the RBC. We don't see any agglutination reaction in the B, but we see agglutination reaction in the RH antisera plus the blood. So this person is the A positive. Similarly, we can see the agglutination reaction in the B antisera and the RH antisera. So this is a B positive person. And in this one, we can see that reaction in all the three. So the A, B, and the RS. So this portion is the AB positive. So the agglutination reaction is widely used for the blood typing. So what are the other usage? As we have discussed, the one of the usage is the blood typing. That is the most frequently used amino acid globally. So hemagglutination inhibition reaction is also used to study the presence of viruses and the antiviral antibodies. One of the example is the influenza virus and bears a primary glycoprotein that is the hemagglutinins. Hemagglutinins mutate, so it is subject to mutation in the selection. So because of the hemagglutinins mutation, there are different strains of the influenza that bear the HA antigen. So, which in turns are bound by the different antibody because if the properties, the structural properties of the antigen will change, it will give rise to the different type of antibodies. So, the antibodies are used in the agglutination reaction for the identification of the different strains of the influenza virus. Similarly, the bacterial agglutination reaction can be used to detect the antibodies to the bacteria. Thank you.